So now we're going to talk about sensory receptors, and we've mentioned sensory receptors a few times throughout the semester. Remember that sensory receptor is kind of the beginning of a feedback loop. A sensory receptor gets information, sends it on to the brain or the central nervous system. Okay, so we've got three main objectives that we're going to get through in the next few slides. Okay, so there are many different types of receptors, and we're going to focus on 6 of them. So we've got photo, chemo, baro, mechano, thermo, and nociceptors. So what do they sense? Photoreceptors sense light in your eye. Chemoreceptors sense chemicals, gases, or pH. And really, pH is just hydrogen ions, so an example of that would be in your bloodstream. Baroreceptors sense stretch or pressure, and again, that's in your bloodstream, in your blood vessels. Mechanoreceptors are something that sense a physical change, like your skin. Okay, you can tell when you've got clothes on, you can tell when you touch something, that sort of thing. Thermoreceptors sense temperature found in your skin. And then nociceptors, they detect pain, and they are located everywhere. All right, now I've got these 4 bolded of photo, chemo, baro, and mechano. And the reason that those 4 are bolded is that we're going to be talking about them more as we go throughout the semester. Now, when it comes to receptors, they don't really have action potentials. They have what are called generator potentials. Okay, it's kind of like a graded potential. Now, sensory receptors are almost always releasing neurotransmitter. Okay, but as their membrane potential or changes, or we have this generator potential, depending on what happens, more or less neurotransmitter is released. Okay, so as generally speaking, not always, but generally speaking, as membrane potential becomes less negative or depolarized, more neurotransmitters released. As membrane potential becomes more negative or hyperpolarized, then less neurotransmitter is released. And we'll get into this a little bit more with our next module in the special senses. Now, one of the interesting things about receptors, about these sensory receptors, is that they experience something called adaptation. Okay, and so with these receptors, just generally, we can classify them as either tonic or phasic. Now, tonic are slow adapting receptors. They fire a lot. The number, the neurotransmitter that's released increases rapidly when they're first activated. Okay. However, over time, this gradually goes away, even if the stimulus is still there. Okay, whereas phasic receptors, they're rapidly adapting. They fire when a signal is first received, but then they stop firing if that stimulus remains. Okay, so in both cases, you have an initial spike, and then one of them decreases a large amount, and one of them basically turns off. Okay, and so with the reason that we have adaptation is this lets us know what's new, what's important, and kind of ignore the old. All right, and an example of this is if, think about when you put your clothes on. Okay, when you first put a shirt on, you can feel the shirt on your body. However, shortly after that, you forget, it's not that you forget, but you just don't even notice that you're wearing clothes anymore. However, if you take that shirt off, or if the shirt moves or something like that, you're more likely to notice it. Same is true of, like a ring or something like that. Eventually, you just kind of are used to it. It's not new, it's not exciting, and so your body just doesn't really react to it. It doesn't pay attention to it. Okay, and this is because of, or this occurs due to the process of adaptation. Okay, so adaptation, initially we're focused on the new, and then over time the new becomes old and it's not as important. So the 3 things you need to be able to do: what are the main types of the sensory receptors? What's the difference between an action potential and a generator potential? And be able to summarize the concept of adaptation.